Hello, in this lesson, we're going to find a tangent line passing a specified point. Once again, please get your paper pencil ready and follow me. You can do whatever with the recording, fast forward, rewind, or replay. Do it before me or do it after me, okay? But make sure you get it, you know how to do it all by yourself. Okay, if you don't need to watch it, that's okay. Okay, because these are selected from homework. Look at the first one. Look at the first one. Okay, the function is root of x squared. I think I will want to have the chain rule written down. Let's see. Okay, chain rule. Okay, but we can write down the chain rule here. Okay. Chain rule is dy dx for y equals to f composite g of x, i.e. f of g of x. Okay. And the derivative is equal to, with respect to x, is equals to the derivative of y with respect to u. U is g of x. Okay, d u dx. So here, u is g of x. Okay, so simply put it that way. Okay, I like this version because it's very straightforward. It's very straightforward. All right, so let's use this version. Okay, let's use this version. I boxed it. Okay, I'm going to put it above it, right? Okay, so in order to find the tangent line, we need to find the slope. In order to find the slope, we're going to find the derivative. Okay, you can see that order. So we're going to do derivative first. dy dx, that's going to be derivative of a root, right? So we're taking derivative of a root function du. And the root is the root of 1 plus x squared, right? So that's our u. That's our u. Multiply du dx. Okay, that's our u there. That's it, right? And this part is the derivative. You don't have to, write that step, and you write it. I'm not going to delete it, but because even though this is optional. So the derivative of root u with respect to u is 1 over 2 times root u. And u, of course, was 1 plus x squared. Oops, sorry. What am I doing here? Okay, so I'm just going to clean this up. There. All right. And derivative 1 plus x squared is 2x. And you can bring the 2x on the top, right? Remove the dot, 2 and 2 reduced. And that's the derivative, right? So then we can say the slope of the tangent line is, right? And we call it m, equals to the derivative evaluated at x equals to 2. right? Because this is the point that's given, right? So this, you can imagine this is x, this is x sub 1, x sub 2, right? X sub 1, x sub 1, I'm sorry, x sub 1, y sub 1, y sub 1. We're going to use that for point slope formula, okay? Equals to, right? So we just directly substitute 2 inside the formula we got. So this is 2, this is 2, and we got 2 over root 5, root 5. You can rationalize it, but if you don't rationalize it, it's not a big deal. So we rationalize it, right? So it's root 5 over root 5. And then we got 2 times root 5 over 5. That's our slope. And the tangent line equation, so a tangent line equation by the point slope formula would be y minus y1, y sub 1 equals to m times x minus x sub 1. Okay, you can put numbers in place directly. 3, and this is 2, and that's 2 times root 5 over 5. Okay, organize the term, you're going to get a y equals to, the slope times x, right? Subtracting 2 times that, right? This piece times 2, that's going to make it 4, right? Adding 3 on both sides. And that is the end. That is the end. So let's look at the next one. Okay, we got 3 questions. We did the first one. So let's look at the second one. Okay, second and third. Okay, second, third, I'm going to move it down here. Here we go. Once again, we want to find the tangent line passing a specified point. Okay. So let me just clean up a little bit. I'll put in the other question afterwards. Okay, so let it wait a little bit. And we have our power rule next to us. Derivative. In order to find the slope of the tangent line, we find a derivative, dy dx, right? In this case, we're going to have to apply product rule first, okay? So we're applying product rule, right? For product rule setup, you differentiate one, right? And then you differentiate the other. That's pretty much it. But this step is optional, okay? I write it here is just to show, to make sure everybody follows. But when you do it individually, you can just go straight. You can go straight to 1 times e to the power of negative x squared, right? You can even omit the 1, right? Plus x times the derivative of that e to the power negative x function, x squared. So you treat it as, this is going to be a chain rule, right? So derivative of e to the power u with respect to u. So let me write it down. Derivative e to the power of negative x squared is our u, du, right? So we're doing this part. And so that's our u. That's our u, and du dx, du dx, du dx. Okay, you don't have to write this explicitly, so you can go straight to the next step, right? And e to the power u differentiated with respect to u is e to the power u. The derivative of negative x squared is negative 2x. Please don't miss this parentheses. If you miss this parentheses, it will be look like this. If it's like this, that's a mistake. Whether you have the dot or not, it will be regarded as a subtraction. Okay, so be sure to have this parentheses with you. Okay, and of course, negative x squared is the power, replacing u. There we go, right? So you can go straight here, really. You can go straight here. Okay, you can omit all of that, just go straight here. Okay, as you're getting better. Okay, but if you're not there, no problem. You will get there. And simplify. Okay, simplify. So we got e to the power of negative x squared, and negative 2x times x, that's going to be minus 2x squared e to the power of negative x squared. And this obviously can be factored out, right? So we factored out that piece, and we got 1 minus 2x squared. So that's the final derivative if you so choose. Okay, I would prefer this form, but you can use this form as well, removing, just simplify that. The other form is okay as well. So now we are ready to find the slope. Okay, slope of tangent line passing the point 0, 0. And we're going to, once again, substitute, assume the slope is m equals to the derivative evaluated at x equals 0, okay? At x equals 0. And that equals to, we're gonna plug in, right? This function, replacing x by 0, 0, dot, we need a dot here. That's gonna be 1, that's gonna be 0, so the final answer is gonna be a 1. And the tangent line passing the point, passing 0, 0 is going to be, the tangent line passing that is going to be y minus 0 equals to 1 times slope x minus 0. So in the end, we got y equals to x. Oh, y equals to x. Done. Finished. Okay, so that's the second question to find tangent line passing a specified point. Let's do the last question for this clip. Okay, one more time. There we go. Okay, same idea. Same idea, but this function is a little bit, we're going to use the chain rule anyway, right? We're going to use the chain rule. So dy dx equals to the derivative of sine, right? The outer layer sine is cosine of sine x, and then we differentiate the sine x inside. I think you guys can follow, right? You can follow. So differentiate the sine outside, and then we differentiate the sine inside. So we got this. slope of the tangent line, right? Once again, we are going to evaluate when x equals to pi. X equals to pi, right? And that will be plugging in here, right? So this is pi, and that's going to be pi. Sine pi is 0. So cosine 0 is 1. Okay? Sine pi is 0. So cosine 0 multiply cosine pi. Cosine pi is -1. So the product is -1. And the tangent line is point slope formula, right? So y minus 0 equals to the slope multiply I, right? The point is right here, right? So finally, the tangent line is y equals to -x plus pi. And we're finished. We're done. Thank you for following me. Thank you for watching.